So now we'll look at section 7C, which is on expected value. And in order to calculate expected value, which will be a formula that we introduced at the bottom of this particular page, you'll first need to calculate the probability model. And I think that'll be very helpful for you. A probability model is just looking at the entire sample space, no overlapping, and calculating the probability that each one of those events happen, and then we'll have an event in one column, the probability of that event in a second column, and we'll move it one step closer or one step further whenever we go to expected value and add a third column, which will be called a gain or loss, and we'll talk more about that in just a moment. But let's first introduce the idea of a probability model, which should be very straightforward given everything we've talked about so far. The probability of an event happening is always between 0 and 1. Okay, you can't have a negative probability and you can't have a probability greater than 1. So probabilities are always between 0 and 1. And then a nice check for yourself when you've done your full probability model is that the sum of all of your probabilities should add up to 1. So I'll be sure to point that out to you. When you create a probability model, I recommend that you list your sample space, make a table for yourself, and then denote the probabilities beside it, and then always make sure that your probabilities add up to 1. So let's go through one of those. Here in example 1, I'm going to toss a coin 3 times, and of course you can get heads or tails on a coin. I want to create a probability model for the number of heads obtained. And so let's first list out our sample space. I think a tree diagram is helpful, so we'll do our first coin toss, and of course we can get heads or tails. And so again, that's the first coin toss. If I go to toss it the second time, then I'm branching off from each one of those, and I can get heads or tails. Then if I go to, this is representing the second coin toss, then if I toss it a third time, then I'm branching off from each one of those twice, and so those represent the third coin toss, and each of those get a head and a tail. We did something very similar, if not this exact problem, in a previous section. Now we go through and I'll list out my sample space so I can get heads, 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 or I could get heads, heads, tails. Like I said before, read these graphs from left to right like you read a book. Heads, tails, head, or heads, tails, tails. Gives you order of your coin toss. Then come down and read your second branch here. Tails, head, head. And then I'm just going to keep going. Tail, head, tail. You can list these in any order that you want to, just as long as you have all 8 outcomes. All right, so we are looking for the probability model for the number of heads. As you can see here from our sample space, it's possible to get no heads at all, just 1 head, or 2 heads, or all 3 of them to be heads. So these are my different possibilities. I can get 0, 1, 2, or all 3 of them to be heads. So now I want to go through and I want to calculate the probability of getting 0 heads. Well, as you can see, that happened 1 time. So 1 out of 8 total possibilities. Probability of getting exactly 1 head. So that happened 1, 2, 3 times. Probability of getting 2 heads. So this happens 1, 2, 3 times. And then lastly, getting 3 heads, that only happened 1 time. So that's what I mean by, looking at, these are all the possible events. You can get 0 through 3 heads. These are probability of each of these events. Then this was the piece I was speaking about a minute ago. You should be able to add that probability column up, and it should give you, in this case, it should always give you 1. In this case, it should give me 8 over 8. And so since their denominators are all the same, they're all 8s, I can add these. 1 plus 3 is 4, plus another 3 is 7, plus another 1 is 8. So I have 8 8s, which reduces to 1. And so then there's my probability model. And so like I said, we're going to just extend this one step further. I'm going to use this probability model, and I'm going to add 1 more column to it for my expected value. And this might be where, hey, you're going to play a game with somebody, and if you get 0 or 1 head, then you win $5, but if you get 2 or 3 heads, then you lose $3. And we would say, okay, well, if you were to play this game over and over again, would you be expected to come out on top or in the hole, kind of thing? So, so expectation is a long-term expected average, whether trying to depict for you whether you would gain or lose if you were to participate in a particular, like I said, a particular game, or you'll see some probably even better examples on the next page of ways that this is used. Um, Expectation. So here's the formula. It looks very ugly, but I promise you that I simplify it for you. But we'll keep it here in a table, and it is all right there in front of you. If you can put the table together, then the formula is very straightforward. But I know that this looks ugly. What this is saying is you can have in as many number of events as you want. So I have here 1, 2, 3 events, but it could go up to K events. You might have 5 or 6 events for some other type problem. But essentially what you do is you take the probability of each event, you multiply it times its amount of gain or loss, add to it the probability of the next event times its gain or loss, and you keep doing that through all of your events, and then ultimately add that together. If that number comes out positive, then you're expected to gain over a long period of time. If that number comes out to be negative, you would be expected to lose over a long period of time. So we should probably just jump into this so that you can see this play out. So essentially, like I mentioned before, create your probability model. It'd be nice for you on the test. The table is sitting right there in front of you to fill in. So that should help you. Make sure that your probabilities add up to 1. Multiply those probabilities by the associated gain or loss, and then add that together, and that's going to give you your, like I said, total expectation. So let's flip it over and let's do one of these. This is something a little more concrete that I think you would sort of, more maybe relate more to. This is, there's TV shows devoted to flipping houses. But in a proposed flipping houses business venture, Stephanie estimates that there's a 60% chance that she'd make $80,000. But flip side, there's a 40% chance that she'd lose $20,000. So we want to figure out Stephanie's expected value for this investment. That, essentially what this question is asking you, if she were to stay in the market flipping houses, and the market stayed under these conditions where she'd gain this much 60% of the time and lose this much 40% of the time, is on average she expected to gain or lose her money? Okay, so what I always tell people is let your probability determine your events. So in this case, they didn't explicitly give us a probability, but they gave us a percentage. And like I said in the previous section, that probabilities can be written as a fraction, decimal, and a percentage. So these percentages then are your probabilities. So here, when you have 60%, that can be written as a decimal. So we can say that is 0.6. That could be written as a fraction, though, as 60 over 100, and 60 over 100 reduced to 3/5. I should say 0.60 when I did that. 60% is 0.60, and then 60 over 100 would be 3/5. Anytime you want to change a decimal to a fraction, of course, you've got your calculator, or you always put it over 100 and then reduce. Okay, so and that 60% represents that she would make money. 40% chance that she'd lose money. So that event is going to be lose money, and that's 40%. So I would say, okay, well, there's 40%. That would be the same as 0.40, and that can be written as a fraction then as 2/5. This is what I was mentioning before. Make sure that that column, when you add it together, gives you 1. 3/5 plus 2/5, sure enough, it's 5/5, so I'm equal to 1, so I'm good to go there. Now let's put a gain or loss in this column. So if you're making money, she's going to make 80,000. So I'm going to put a positive 80,000 there. If she's losing money, she's losing 20,000. And because she's losing it, you're going to put a negative. Not every problem has a positive or a negative in it. Some problems have all positives, some have all negatives, some have a mixture, as you can see here. So, but if it's a loss, you're going to denote it with a negative. Here's now, we want to find Stephanie's expected value. We want to use our formula that was on the previous page. The formula said you take the probability of the event and multiply it times its associated gain or loss. So I'm taking that probability 3/5. Here I made a note on the solution key that since this decimal is a nice clean number, you can use this decimal. You'll see in a moment that I'm going to be forced to use my fraction because my decimal is going to require me to round, and you don't want to do any rounding until the very end of your problem. So you can use 3/5 or you can use 0.60 in this case. So I'm going to use the 0.60. So 0.60 times its gain, 80,000. Formula then said add that to next event. So next event is losing money. That's a 40% chance. So 0.40 times negative 20,000. Its associated gain or loss. Okay. Then I just, so this is my expectation here. That's using my formula. If I had another event, I just add more on to it. You should be able to put that in your calculator all at one time and get your final answer. I'll show a little bit of work here. 0.60 times 80,000 should give you 48,000. 0.40 times negative 20,000 should give you negative 8,000. Add those two together and you have $40,000, and it's positive. So you might be asking, okay, well, that's fine and dandy. What does it mean, though? And so that's why I put this sentence underneath here. This means that in the long run, because expectation is that, is a long-term average, her flipping houses and the market staying under these exact same conditions. So this means in the long run, if Stephanie continues to make this same investment many times, not just one time, not just 2 times, not even 5 times, many times, under similar conditions, meaning the market's going to stay the same, she will be expected to gain, because this number is positive. If it were negative, we'd say lose. An average of, in this case, $40,000. Okay. I'll let you then work through example 2 and 3. I think I've shown good notes on the solution key to be able to follow through with that. I'm going to flip on over then to our next page and look at example 5. This one's a little different because up until, whenever hopefully you would have paused the video now and worked on example 3 and 4. Up to this point, your losses and gains haven't had, you've had it, it's been straight out, exactly what your loss and what your gain is. Sometimes though you, for example, pay to play and you have a net winning or a net loss. And so let's look at how that plays out in the next 2 examples. So in example 5, it says you're playing roulette and you bet $1 on the number 10. So if 10 comes up, you win $35. If anything else comes up, you lose your dollar. We want to know what's your expected value for this bet. And then in case you didn't know, on a roulette wheel, there are 38 numbers. So you can either get a 10 to come up, so I'll say my event, a 10 comes up, or anything else. So I'll just put here anything else. What you label your events to be is of no consequence. It really is based solely on the probability and the losses and gains, making sure you've got those correctly attached to one another. So a 10 coming up in this case would be there's only one 10 on the board or on the wheel out of 38 possibilities. This is what I was speaking about a minute ago. If you do 1 divided by 38 in your calculator, it is not a nice clean decimal. So I don't want it, and so at this point, if I tried to use the decimal, I would have to round it. I don't want to do that. So I'm keeping that as a fraction. So that should be your thought process as well as you work through these. Anything else then to come up, then that's going to be the other 37 numbers on your wheel out of 38. Add those 2 numbers together. 138 plus 37 38s gives you 38 out of 38, which gives you 1. That's your check. If a 10 comes up, you're going to win $35, but you had to pay $1. You bet $1. So you're subtracting your 1, so you're only going to be up, really, technically, $34. If you lose, then you're just out the $1 that you betted up front. Okay? So now let's find our expectation. So our expectation is equal to probability of the event, so the first 1 out of 38 times 34. And you can put that like 34 over 1 plus second probability, 37 out of 38 times its associated gain or loss, so -1. I'm just going to put it over 1. I do that here. I know you got a calculator. Feel free use your calculators, but this is a way I can show a lot of work here. Then what I'm doing is I am multiplying straight across. So 1 times 34 is 34. 38 times 1 is 38. Plus 37 times negative 1, that's negative 37. 38 times 1. Now because you have the same denominator, I can just add across. I got 38. 34 minus 37, of course, is negative 3. So I have negative 3 over 38. Since we're talking about money, I would go ahead and divide that out, and you would have a negative 0.08. So if you were to play this roulette multiple times, same type of bet, you would be expected to lose, because that number's negative, an average of 8 cents. So 0.08. Okay. Another important type of problem that you'll see associated with expected value is a raffle, and you probably have participated in a raffle before. So definitely be sure that if you might want to watch this particular part a couple of times just to make sure that you're following this, because you'll definitely see this again. 2,000 raffle tickets are sold, $5 each. 4 prizes are awarded: one $1,000 prize, one $500, and two $100 prizes. Ken bought 1 ticket. And so we want to figure out, well, what's Ken's expected value? Is he expected to come out on top or behind? So, as you can see, he could win $1,000. He could win $500. He could win he could win $100. I don't need to write win 100 twice. I know that there are 2 of them, 2 winnings there. I'm going to be able to put that 2 into the probability, because these are the prizes that you can win, but you could also lose. Okay. Probability that you would win $1,000, well, since there's only 1 prize, 1 out of the 2,000 total tickets sold. Winning $500, 1 $500 prize out of the 2,000 tickets sold. Winning $100, there are 2 of those prizes out of the 2,000. So you've got a greater chance of winning $100. Losing, then, it's still got to be out of 2,000, because remember, this column needs to add up to 1, so this column needs to add up to 2,000 over 2,000. So right now I have 2, 3, 4, just adding up these numerators, 2, 3, 4. I do 2,000 minus 4, that's 1996. So there's 1,996 people, or I should say tickets, losing tickets. One ticket holder is going to win $1,000. 1 ticket is going to win $500. 2 people are going to win the $100, and then the other 1,996 tickets are going to be losing tickets. Okay. Again, 1996 plus 2 plus 1 plus 1 is going to give me 2,000 over 2,000, which gives me 1. All right. So if you win $1,000, you are winning $1,000. But you've got to take into account that you bought your ticket $5. So technically, you're only going to be net winnings of $995, because I'm taking my $1,000 winnings but subtract out the cost to play. If you win $500, then your net winnings would be $495, because again, 500 minus 5. Win $100, and that's going to be 100 minus 5. And that's going to be $95 in winnings. And then if you lose, you're just out the $5 to play. So now let's find our expected value. One thing should be noted, yes, these bottom 2 probabilities could have been reduced. It's easier, though, if you keep them not reduced, because then you can easily eyeball that, this column needs to add up to 2,000 over 2,000. So if you don't reduce it, it makes it a lot easier to make sure that you're adding up to 1. So my expected value, and this one's a lot more detailed. Again, I'm showing all my work, all my steps here. If I were doing it by hand, I know you have a calculator. Take the probability of the first event, multiply it times its gain, 995. Next event, 1 over 2,000 times its gain, 495. Next event, winning $100, so probability is 2 over 2,000. times $95 for its winning, plus last event, which is losing. Its probability is 1996 over 2000, and I multiply that times -5. So now you got all this multiplication division. Of course, multiplication needs to come first. So 995 times 1, 995 over 2000. I'm just multiplying straight across, doing each one of these. So now if I multiply this out, I'm going to have 495 over 2000. Multiply this out. 2 times 95 is 190 over 2000. Lastly, 1996 times -5 is going to give me -9980. 2000 times 1, of course, is still 2000. Now, me personally, this is what I always do, and then now is the only time when I go to my calculator. 995 plus 495 plus 190, and then subtract 9980 should give you -8300. Divide that out. We're talking about money, and you should get -415. So -$4.15. Final answer for my expectation. So you would be expected to lose $4.15 if you were to participate in this raffle many, many times. This leads us into the next topic, which is called a fair price. And the fair price of a ticket is basically your break even, where those the people holding the raffle don't lose any money and they don't gain any money. Likewise, you don't lose and you don't gain any money. Okay, it's that break even. Fair price is always your expectation plus the cost to play. So here our expectation was -415. Add to that the cost to play, which was $5, and that should give you 85 cents. So for example, what this means then is if they were charging 85 cents for the tickets, that would be a fair price. There was one other thing I was going to mention about these. You might be saying, well, goodness, I never want to participate in a raffle again. That's sort of the nature of a raffle. Raffles are not designed for you to make money. It's designed for that particular organization to make money. A lot of times even these prizes are donations that they receive from the community, so they're able to pull in all of that money. So for example, this raffle, 2,000 times 5, they're bringing in $10,000 total, and if all of these winnings then were donations, then they have generated for themselves $10,000. So like I said, that's the nature of a raffle, that you shouldn't expect this to be positive. Okay, I will flip it over to the last page, and I think I will do the first part of this one and then leave the rest for you. In example 7, perhaps you've ever taken the SAT, and whenever you take the SAT, there are 5 possible answer choices, A through E. For each for each correct answer that you get right, you get 1 point. But if you get a question wrong, they deduct 1/4 of a point from your score. Leaving an answer blank doesn't add or subtract. So we want to figure out what's a person's expected value for a problem if the answers are just filled in at random. Okay, so obviously when you answer a question, you can either get it right or you could get it wrong. Probability of you getting it right is answering it correctly out of those 5 answer choices. So then that would be 1 out of 5, because there's going to be 1 right answer out of the total 5 answer choices. Probability of you getting it wrong then the other 4 answer choices are wrong out of the 5. If you get it right, you're getting a point. If you get it wrong, you are losing 1/4 of a point. Expectation, nothing different than what we were doing previously. Probability of the event times its associated gain or loss, plus probability of the next event times its gain or loss. Multiply straight across. I have 1 times 1 over 5 times 1, plus 4 times -1 over 4 times 5. And then if I add that 4 over 20 could be reduced to 1/5. You would see -1/5. You would see that when you add that, you would get 0. So what that means then is that your expected value here is 0. That really guessing is not harming you. You're not gaining any points. You're not losing any points. So it doesn't give you any specific advantage in the long run. However, the results might be a little different if you could eliminate one of the answer choices, and that's what Part B looks at. So it says, okay, well, if you can eliminate an answer choice, do you end up coming out ahead each time or behind? So that's what you will look at there in Part B. Again, the homework in this section was not ideal for what we were looking at here with expected value, so definitely consult the supplemental homework that I have for this section to help you with practicing a little bit more with this and getting ready for the quiz.